Go outside tonight. Look up. 2,000 stars are visible. The galaxy holds hundreds of billions. It has been here more than 13 billion years. That is the part that should disturb you. Settlement models built on slow ships and long pauses still fill the Milky Way in a fraction of that time. The numbers shift with every assumption. All of them are shorter than the galaxy's history. A civilization with a modest head start had time to spread, to leave probes, structures, descendants, wreckage, before anything on Earth could walk. We have found none of it. No confirmed artificial signal. No unambiguous astroengineering. No verified artifact anywhere. We have not searched everywhere either. That matters more than it sounds. 10 answers follow. Empty worlds. Dead civilizations. A galaxy that may be occupied and quiet. The last does not claim nobody is there. It asks whether being visible is the one mistake an old civilization learns not to make. Call it a paradox, and you have already made an assumption. This is a tension, not a contradiction. It holds only if technological life arises often, lasts a long time, spreads at least once, and would have been noticed. Loosen any of those, and the tension slackens. The question is not whether microbes exist somewhere. It is about technological detectability across galactic history. 10 answers follow, drawn from 5 different disciplines. They do not have equal standing. Some reduce how many civilizations arise. Some shorten how long they last. Some block expansion. Some attack the searches. Some make claims about alien behavior that no instrument can test. And there are 3 separate silences. No signals, no visible engineering, no artifacts. An answer that explains one does not automatically explain the others. Watch which one each answer can actually reach. Los Alamos, summer 1950. 4 physicists walk to lunch. Enrico Fermi asks where everybody is. The line survived, the context did not. Accounts from the men in the room suggest he was doubting interstellar travel, not doubting life. He never published a paradox. Before you explain a silence, check how loud your expectation was. The expectation may be the error. The Drake equation organizes the unknowns. It does not measure them. One of them, how often life starts, rests on a single example. A critique of the prior, not a mechanism. Drake wrote his equation in 1961 to structure an agenda, not to compute an answer. Exoplanet surveys transformed the first 3 factors. The last 4 have not moved at all. Here is where the arithmetic goes wrong. Take a plausible middle value for each unknown and multiply, and you get a comfortable number of civilizations. A middle value is not a measurement. If honest belief about the origin of life spans dozens of orders of magnitude, the middle is not a place to stand. Propagate the full uncertainty, and you stop getting a number. You get a distribution. Wide enough to put real probability on nobody being within reach, while still allowing a crowded galaxy. One much-discussed analysis did exactly that, and reported a substantial probability that we are alone. It remains a preprint, and the result depends heavily on which published ranges you accept. It shows what uncertainty does to arithmetic. It does not count our neighbors. And expected number is not probability of existence. A model can average thousands and return 0 most of the time. The strongest thing this answer has is the size of our sample. One planet, one origin of life, one technological lineage. Every rate past the astronomy is estimated from a single case, by a member of that case. Exoplanet science made this harder, not easier. Rocky worlds in temperate orbits are common, so the denominator is enormous. That says nothing about the numerator. Habitable describes a place. Inhabited is a claim about what is in it. The history sharpens it. Michael Hart published the argument in 1975. They are not here, therefore they do not exist. Hart called that absence fact A. Fact A is real. It is a reductio, not a proof, and what follows from it is a chain of assumptions. Leave the astronomy alone and move one number. Keep every star. Keep every rocky planet in every temperate orbit. Change only the probability that chemistry becomes biology, and lower it by 6 orders of magnitude. The expected population of civilizations in the Milky Way collapses from thousands to less than 1. Nothing observable changed. You adjusted a quantity nobody has measured. Run it the other way, and the galaxy fills. The answer is dominated by a number nobody can constrain, on which we hold one data point. It is you. None of this explains the absence of things. Probability arguments reduce the expected number of civilizations. They say nothing about what happened to the ones that arose. And the colonization argument does not need many. It needs one. One lineage, anywhere, across 13 billion years that built durable machines and let them replicate. Uncertainty about rates cannot make physical objects vanish. Defenders reply that a low enough rate drops expansionist lineages below 1 across all of galactic history. Coherent, and a far stronger claim than we are uncertain. It requires the rate to be not merely unknown, but genuinely minute. So this answer cannot stand alone. It clears away false confidence. It does not fill the space it empties. If this is the answer, the sky is not strange. Our expectation was. The search changes meaning. Every null result becomes a constraint on an open question rather than a failure. The consequence for you is not comfort. If the number really is near 1, the capacity to ask this question is not a stage matter reliably reaches. It happened in you. Uncertainty is not a mechanism. Saying the number could be small does not tell you which step makes it small, and there is an obvious suspect, the first one. Before biology, before evolution, before anything could be selected, chemistry had to cross a line. Nobody has watched it happen. Not once, not even in a laboratory built to force it. For 70 years, chemists have been trying to make life. Amino acids from lightning in a flask. Nucleotides from early Earth chemistry. Vesicles that grow and divide. RNA that copies pieces of other RNA. Not one experiment has produced something that reproduces, mutates, and evolves with no chemist in the room. We can build the parts. Nobody has watched the machine start. Habitable may be ordinary. Alive may be almost impossible. Not that biology is forbidden, that the crossing into self-sustaining Darwinian evolution happens on a vanishing fraction of suitable worlds. Put the filter at the first step, and this answer reaches all 3 silences at once. 4 things have to arrive together, and each is difficult alone. A boundary, so chemistry stays concentrated instead of dispersing. An energy supply the system can keep tapping. a molecule that carries information and can be copied, and a link between all three so that copying the information changes what the system does, and what it does affects whether it copies again. Any one is achievable in a laboratory. Getting them coupled, sustained, unsupervised is the unsolved part. The copying step carries a further trap. Above a certain error rate, information degrades faster than selection can preserve it, and nothing accumulates. Below it, evolution starts. Keep 4 stages separate because they get collapsed constantly. Prebiotic chemistry is molecules forming. Protocells are compartments that grow and split. Self-replication is a molecule copying itself. Darwinian evolution is a population that varies, inherits, and is selected. Only the last is life in the sense that matters. The last universal common ancestor was not the first life either. It was already a sophisticated cell, the product of an unknown stretch of prior evolution. We can reconstruct our ancestor. We cannot reconstruct our beginning. Panspermia rescues nothing. Move the origin to Mars, and you have changed the address, not the odds. The case for rarity rests on something quietly devastating. Every organism ever examined shares one genetic code, one chirality, one ancestry. Life on Earth started once, as far as any evidence shows, and never started again. Earth has been warm, wet, and chemically rich for billions of years. If abiogenesis were easy, a second unrelated biosphere should turn up somewhere. Nobody has found one. Searching is hard because the existing biosphere consumes everything. The expectation is not being met. Europa and Enceladus have had liquid water and chemical gradients for a very long time. Neither has shown us anything. That proves nothing yet. It is also not encouraging. Replay this planet. Earth at 4 billion years ago. Same ocean, same vents, same organics. Run it forward 1 billion years, 1,000 times. How many runs produce a self-sustaining, evolving population? The honest range spans almost every run, to 1 in a number with more zeros than there are atoms in the galaxy. No experiment distinguishes them. You are the output of a process whose probability you cannot estimate using a brain that process built. Life on Earth appeared fast. Earth formed roughly 4.5 billion years ago. The earliest widely accepted microfossils sit near 3.5 billion. Life showed up near the front of the record. A Bayesian analysis of that timing found the evidence favors rapid abiogenesis, a little under 3 to 1, rising toward 9 to 1 if you accept the disputed older evidence. Not overwhelming. It points one way. The reply is a selection effect, and it is not a technicality. You could only be here to notice the timing on a planet where life started early enough for intelligence to evolve before the star heated up. Late-starting worlds produce no observers to report the delay. If the first spark is the filter, the search has been pointed at the wrong target for 60 years. Radio telescopes assume someone is transmitting. On this hypothesis, nobody ever will, because nothing ever begins. The instrument that settles it is not an antenna. It is a probe under an ice shell. 2 independent origins in one solar system would demolish this chapter overnight. 2 sterile oceans, thoroughly examined, would sharpen it considerably. Every point of light above you may hold an ocean. Warm, wet, ready, never crossing the line. Suppose it does cross. Suppose life is easy. Your own planet still spent roughly its first 2 billion years as a world of single cells and nothing else. No animals, no plants, no eyes. Life is not the same achievement as complexity, and the next bottleneck sits a very long way after the first. Life on Earth is roughly 3.5 billion years old. Animals are roughly 600 million. For most of that gap, this planet was single cells. No plants, no eyes. Then, one cell got inside another and was not digested. Everything you would recognize descends from that merger. Life had 2 billion years to repeat it. It never did. The galaxy may be biologically busy and almost entirely microbial. Life is not the bottleneck here. Complexity is. Every silence stays intact. No signals, no structures, no artifacts, because nothing on those worlds gets large enough to make any of them. The evidence is contested, and Rare Earth hides several different claims. Separate the transitions, because piling them into one story is how this argument gets abused. The first is the cell that became a cell within a cell. An archaeal host acquired a bacterium and turned it into the mitochondrion, producing the only kind of cell that has ever built a large organism. One argument holds it was decisive for energetic reasons. Bacteria pay for power across their outer membrane, which scales badly. Mitochondria change how much energy a cell can spend per gene. Complexity was blocked by a power supply, not by imagination. That reading is disputed. The second is atmospheric. Oxygen rose in a first major step around 2.5 billion years ago and reached modern levels much later, close to the appearance of animals. Large, active, oxygen-hungry bodies were not possible before that chemistry existed to support them. The third is multicellularity, and here the argument weakens on purpose. Simple multicellularity evolved many times. Complex multicellularity, with differentiated tissues, evolved a few. Notice what has not been claimed. Not a large moon, not plate tectonics, those fill popular versions and none is established. The strongest case is a pattern in the only planetary record anyone has. Life appeared quickly and then did almost nothing for an extraordinarily long time. Roughly 1 billion years in the middle of Earth's history are so quiet that geologists gave the interval a dismissive nickname. Against that, eukaryogenesis stands out. Eyes evolved independently many times. Flight evolved separately in insects, pterosaurs, birds, and bats. Evolution repeats its useful solutions, which makes the singularity of the merger strange. A microbial biosphere is also stable. Nothing selects for complexity, and it can persist unchanged until its star kills it. Complexity is not a destination. It is a contingency. And the timing is tight at our end. Earth has perhaps 1 billion years left before a rising solar output makes complex life untenable. A slightly slower world runs out of time before producing anything that could look up. Point our best future telescope at a world like that. Oxygen, methane in disequilibrium, water. A living planet, unambiguously, at a distance you can name. Now ask what you have found. A microbial ocean, 2 billion years old. Chemically loud, biologically real, and completely without anyone in it. A signature of metabolism, not of minds. Living worlds may be common, and inhabited worlds almost non-existent. And a biosignature cannot tell the difference. One planet cannot establish which steps are universally hard. Every claim here is an inference from a single chronology. Something happening once is compatible with it being nearly impossible. It is equally compatible with it being ordinary but leaving no second trace because the first lineage took the niche. A 2025 reassessment reframed the approach. Rather than treating the long delays as evidence of improbability, it argued they were gated by planetary conditions. Humanity did not arrive late against the odds. Humanity arrived on schedule. Defenders answered that gating does not explain why the merger has no known second instance. This will not be settled by argument. It needs a second biosphere. If complexity is the filter, we have been searching for company, and we will find neighbors instead. The galaxy would be alive. Oceans, atmospheres, ecosystems older than our sun. And silent, because a biosphere without complex organisms leaves nothing but a spectrum. The statistic to watch is not how many worlds show oxygen. It is what fraction show anything more, and it recasts what you are. Not an endpoint planets reliably reach, a passenger on the one branch that included a merger, an oxygenation, and a body plan. The planet owed you none of them. Even complexity is not enough. Earth carried complex animals for 500 million years without producing a single transmitter. Dinosaurs held this planet for over 100 million and left no instruments. Between a nervous system and a radio telescope lies a gap that your own history crossed exactly once. Somewhere under an ice shell, in an ocean that has never seen a star, something is thinking. Give it everything. Memory, curiosity, problem-solving that would embarrass a human child. It will never smelt metal. Fire does not burn underwater. It will never do astronomy. There is nothing overhead but ice. A failed intelligence? Or a successful one, where your definition of success is unavailable? The chain from cognition to detectability has more links than it appears, and each fails independently. Start with what distinguishes humans, because it is not raw intelligence. Many animals solve novel problems, use tools, plan, deceive. What our lineage has is cumulative culture. Improvements passed forward, so each generation starts where the last stopped. Without that ratchet, a species reinvents the same solutions forever. The ratchet needs machinery, high-fidelity social learning, language or something equivalent, and groups large enough that skills are not lost when individuals die. Then the environment gets a vote. And here the argument becomes concrete. Metallurgy needs sustained high temperatures. High temperatures need combustion. Combustion needs an oxidizing atmosphere and dry material to burn. A species under ice is not lacking imagination. It is missing the chemistry. Astronomy needs a transparent sky. A world under permanent cloud produces nobody who knows other stars exist. Radio needs a reason, and ours came out of a specific industrial history. Every one is a filter, and they multiply. Earth is the evidence, and Earth ran the experiment repeatedly. Cetaceans with vocal culture that persists across generations. cephalopods with distributed nervous systems, corvids that manufacture tools, elephants, primates, parrots. Not one built a transmitter. Over hundreds of millions of years of complex animal life, planet-scale technology appeared once, in one lineage, extremely recently. The only base rate available. Roughly 70% of this planet is water, and the most cognitively impressive non-human lineages are in it. Work on the physical requirements for technology suggests dry land, fire, and atmospheric transparency may matter more than intelligence does. Many habitable worlds appear to be ocean worlds. If that holds, the typical intelligent species may be permanently sealed away from the sky. Replay Earth again, but start much later. Rewind to the end of the Cambrian. Nervous systems, bodies, eyes, ecosystems. The hard biology is done. Run it forward 1,000 times. How many runs build radio telescopes? On the one run you can observe, it took most of that 500 million years and required a single mammalian lineage to survive an asteroid impact. Dinosaurs held this planet for over 130 million years. Dominant, diverse, successful. They left no instruments. Rare is not never, and the galaxy is very large. Suppose the odds of a complex biosphere producing a technosphere are 1 in 10,000. Across billions of worlds, that still yields an enormous number. And the colonization argument needs only one to be old and expansionist. Evolution also repeats itself. Tool use has appeared independently in several lineages here. If cognition and manipulation are convergent, the path is less unique than one planet suggests. Defenders reply that convergence has limits. The same environment produces the same solutions, which is the point, because most environments are not this one. A convergent solution to swimming does not deliver metallurgy. The claim was never that technology is impossible elsewhere, only that the conditions for it are rare. If cognition rarely becomes technology, the nearest mind is not silent by choice. It is silent by architecture. Listening for deliberate signals assumes a species that knows there is something to signal to. The useful targets become planetary. Anything that betrays intelligence without requiring intent. And it makes something about you unusually specific. Not your intelligence, your sky. You could see the stars, breathe an atmosphere that burns, and stand on ground dry enough to build on. Those are planetary accidents, and they may be the rarest part of the story. Rare still happens, given enough time. And the galaxy has had 13 billion years. Even a 1 in a billion path should have run many times by now, so the difficulty may not sit in the biology at all. It may sit in the clock. The universe may only recently have become the kind of place that could produce you. 4 answers. 1. Arithmetic. Start with hundreds of billions of stars. Remove the worlds where chemistry never crosses into biology. Remove the biospheres that stay microbial. Remove the complex ecosystems that never produce cumulative culture. Remove the cultures that never build anything a telescope could see. Each cut is a multiplication by a small number. 4 in a row can take an enormous starting population down to something close to 1 without any single step being impossible. That is the shape of the empty galaxy answer. Not one catastrophe, attrition. But attrition has a weakness. A rare event in an old galaxy still happens, and 13 billion years is a great many attempts. So the question changes. Not how hard intelligence is to make, when the universe became capable of making it at all. Look at the sun, and you are looking at an unusual star. Most stars are red dwarfs, burning for hundreds of billions of years, by some estimates, trillions. The sun has about 5 billion left. The universe is 13.8 billion years old, barely underway. The quiet sky may be what an early morning looks like. We may not be rare. We may be first or close to it. The conditions that permit observers may only recently have arrived. Or the steps may take so long that few lineages have finished. These are anthropic, time-dependent models. Several are contested, and none is settled. Two very different mechanisms produce the same result. The first is the hard steps model. The sun will render this planet uninhabitable in roughly 1 billion years. Intelligence appeared after about 4.5 billion. That is late. If the steps are improbable and the window has a deadline, finishing near the end is expected. Most worlds run out of time. The second puts the delay in the planet instead. Complex cells waited on the oceans and atmosphere. Animals on oxygen. Nothing was waiting on luck. The difference matters. Under hard steps, Earth got lucky and most worlds fail. Under environmental gating, other worlds arrive on their own schedules. A third version is more speculative. Some models propose that expanding civilizations claim large volumes fast, so any observer must predate the claim. Those are explicitly anthropic constructions that generate predictions, not observations. The timing argument has real quantitative work behind it. A 2021 analysis modeled Earth's transitions as a sequence of improbable steps and inferred that technological intelligence should be rare. It is an inference from one timeline, and the authors say so. Then, the star you orbit. Red dwarfs vastly outnumber sun-like stars and last far longer, and rocky planets around them are common. If observers arise readily there, most observers who ever exist should see a red sun. You do not. Humanity looks like roughly a 1 in 100 outlier. That is a real anomaly, the red sky problem, and it demands an answer. Either those worlds are less habitable than they look, or observers really are early. If the universe runs for trillions of years, everything so far is the opening act. So answer the question directly. Why here? You got one of the rarer, shorter-lived stars in the first 14 billion years of a universe with trillions ahead. Only a few ways out. Either red dwarf systems cannot support observers, and the galaxy's most abundant real estate is dead, or almost nobody has finished yet, and you are near the front. Or you are an unlikely draw. The first is empty. The second is empty now. The third means nothing follows from your position at all. Each is a different galaxy. Nothing currently distinguishes them. Anthropic reasoning bends to whatever you assume before you start. These arguments run on priors. Change a prior, and the conclusion moves. The 2025 reassessment is the strongest version. If the delays in Earth's history were environmental rather than probabilistic, the hard steps inference collapses. The evidence for improbability was always the waiting. Red dwarf habitability is genuinely unresolved. Flares, tidal locking, and atmospheric loss may make those worlds far worse than their numbers suggest. If so, the red sky problem dissolves. The deepest problem is simpler. Being early explains why the galaxy is not saturated. It does not explain why nobody arose a few 100 million years before us, right here. If humanity is among the first, whatever you do next is the opening move in a galaxy that has not yet been played. And your loneliness is temporary, just not on any time scale that helps you. Early does not mean alone. Even a slow, time-gated galaxy should have produced someone 100 million years ahead of you, a trivial interval out here. If it did, the question is no longer why they never arrived. It is what happened to them after they did. Stop for a moment, before the film turns. Everything so far has argued that almost nobody arrives. Everything after this argues that they arrive, and then vanish, stay home, or become invisible. Choose now, while it still feels obvious. Where does the strongest filter sit? One word is enough. Origin, complexity, intelligence, timing, survival, expansion, visibility, intention. None. Leave it below. Then find out whether it survives the second half. Count the interval. The first deliberate radio transmission crossed a room in the 1890s. The first nuclear weapon detonated in 1945. From "we can send a signal" to "we can erase the sender" took roughly 50 years. Another 50 to altering the planet's atmosphere. 1 century of detectable human technology. Long enough to be seen, not long enough to prove we survive being the kind of thing that can be seen. You are standing inside it. So did everyone who ever transmitted. The improbable step may be in front of us. Something must make technological civilizations rare. If it is not in the biology behind us, it lies between a young technological species and an old detectable one. This framework says something filters. It does not say what, and it reaches the silence of signals and of visible engineering far better than the absence of physical artifacts. The logic runs backwards. The end point is not common because we cannot see it. So somewhere in the chain sits a step almost nothing gets past. Every filter you move behind you must be replaced by one ahead. If life is easy, if complexity is ordinary, if intelligence is common, the improbability has nowhere left to sit but ahead. 4 outcomes get collapsed into the word extinction. A species can die. A civilization can collapse while the species survives. A society can lose the technology that made it visible, or it can transform. Only the first is an ending. All 4 produce silence. The Drake equation's lifetime term is where this bites. Change it from 10,000 years to 100, and the sky empties without a single extra death. One inference needs care. A second, independent origin of life would push the filter forward, but only if it is genuinely independent rather than shared with Earth through material exchange, and only by an amount that depends on what you believed beforehand. A real argument, not a verdict. The case rests on a mismatch we can observe in the only civilization available. Technological capability grows fast. The institutions that govern it do not. A species acquires the ability to alter its atmosphere, edit biology, and destroy its own infrastructure. The means of coordinating them arrive much later, if at all. The gap is a description of the last 100 years. And a detectable phase needs sustained industrial capacity, sustained scientific institutions, and enough peace to keep both running, across centuries at minimum. Each can fail on its own, and each failure ends the signal without ending the species. The same energy that makes a civilization visible makes it dangerous to itself. Visibility and risk may be the same property. The galaxy does not need to kill everyone. It only needs the typical detectable phase to be short compared with galactic time. Put humanity in the corridor. You are roughly 100 years into a technological phase. You hold capabilities that did not exist when your grandparents were born, governed by institutions designed before any of them were invented. If every civilization passes through a corridor like this, what fraction emerges intact? The Drake equation calls it the lifetime term. You are inside the experiment that would measure it. The silence is one possible readout. Collapse is not extinction, and one survivor is enough. Human history is full of collapsed civilizations. None ended the species. A galaxy that repeatedly rises and falls is not silent. It is intermittent. The harder version is the durable artifact problem. Probes do not need their makers. Industrial atmospheric chemistry persists on geological timescales. If millions of civilizations arose and died, the wreckage should be somewhere. Defenders reply that the filter may catch essentially all of them. That is consistent. It is also a much larger claim with no evidence behind it. The framework is real. The mechanism is missing. Nobody has identified a danger that would reliably destroy every technological civilization. If the filter is ahead, the silence stops being an astronomical fact and becomes information about us. Not a prophecy, a prior. It would mean the base rate for surviving this is low. Finding a second, independent origin of life nearby would be the worst good news in history. Wonderful and quietly terrible. Not expansion, not energy, duration. The test is whether you are still here in 10,000 years. The night sky becomes a record of how long they lasted. A civilization does not have to die to vanish. It could survive completely, stabilize, and simply never leave home. The whole paradox rests on an assumption nobody has examined closely enough, that anyone who can cross between stars eventually wants to. The argument that makes the sky feel wrong is not an observation. It is an extrapolation. Build a ship that reaches another star. Build 2 more there. Repeat. Michael Hart ran the arithmetic in 1975. A galaxy crossed in a few 100,000 years. Frank Tipler, with self-replicating machines in 1980, got a few 100 million. Every step is physical except one: what anybody would want. Surviving and spreading are different things. Civilizations may last indefinitely without turning the Milky Way into an empire. Settlement may move in slow, patchy waves that stall and leave enormous regions untouched. This answer targets artifacts and visitation rather than signals. 3 mechanisms are usually bundled together. They should not be. The first is chosen restraint. Indefinite exponential expansion is not sustainable. The civilizations still alive may be the ones that stopped growing. The second is logistical failure, which requires no wisdom. Each settled system launches further expeditions with some probability. Below a critical threshold, expansion percolates instead of filling space, leaving voids of unvisited stars inside a settled region. The third is the galaxy itself. Stars drift past one another over hundreds of millions of years, Include that motion, and expansion becomes diffusion rather than an expanding sphere. Those models produce steady states nobody expected, a persistent population of interstellar civilizations, while a substantial fraction of settleable systems sit empty. The modelers named that outcome after a novel in which a settlement mission arrives and fails, the Aurora effect. Some systems look habitable from a distance and are not, and a wave that keeps striking them stalls and leaves permanent gaps behind it. Hart's fact A was supposed to imply that nobody is anywhere. In a patchy galaxy, an unoccupied system is ordinary. The settlement models are the strongest case because they are the only part of this subject where the assumptions are written down and the consequences computed. Ship speed, launch rate, how long a settlement waits before expanding again, whether it expands at all. Vary those, and the model produces everything from saturation to permanent patchiness. The Hart-Tipler conclusion is one output of that space, not obviously the most likely. And there is a plain physical point. Interstellar settlement is enormously expensive and returns nothing to the people who pay for it. A civilization does not need a philosophy of restraint to stay home. It only needs better uses for the resources. In every budget cycle, grant humanity the capability, and watch what happens to control. You build one self-replicating probe, strict limits, replicate twice, then stop. It obeys. Now run it forward 10,000 generations with no communication back. Copying errors accumulate. Any lineage whose limits degrade outcompetes the ones whose hold. Restraint is not a property you install once. It must be maintained across a population you cannot reach. Universal restraint is not required. One defector is enough. This chapter needs no civilization to expand. Not a splinter culture, not a corporation, not a rogue probe. Across 13 billion years. One lineage that abandons the norm has hundreds of millions of years to fill the galaxy. The weak reply is that advanced civilizations converge on the same conclusions. Alien psychology dressed as an argument. The strong reply requires no restraint. The percolation and diffusion models produce patchy outcomes even when civilizations try to expand. It needs only interstellar settlement to be hard. It holds for the local silence, not for why nothing large is visible anywhere. If expansion is not inevitable, the paradox loses most of its force and keeps all of its interest. An empty solar system stops being surprising. Fact A becomes a local observation. The targets become individual systems. Nothing would be crossing your sky. Everything would be sitting still. It offers the one hopeful reading available. A species can be permanent, or it can be expanding. Choosing the second may be how you fail to be the first. Staying home is not the same as staying quiet. A civilization that never leaves its star can still light it up, transmit for centuries, burn hard enough to be seen from 1,000 light years away. So the question is no longer whether they travel. It is whether they were doing anything visible during the brief window in which you happened to be looking. The galaxy does not fill itself simply because travel is permitted by physics. Someone has to survive the corridor. Someone has to want to go. Someone has to keep wanting it across generations that will never learn the outcome. Every one is a place where expansion stops, and none requires anybody to die. Not empty, occupied, local, and staying that way. Except that a civilization which never leaves its system can still be seen. so the silence now needs three more things. That their visible eras did not overlap with ours, that we know what to look for, and that none of them decided, deliberately, to be difficult to find. A signal left a star, 500 light-years away. It was deliberate. It was strong. It swept over Earth and kept going. The year here was 1520. Nobody had a receiver. Nobody had the concept of a receiver. It passed through the bodies of everyone alive. Both civilizations existed. Neither ever knew. The galaxy may be crowded across time and empty at any given moment. Civilizations could arise repeatedly and almost never coexist. This explains the silence of signals well. It explains the absence of durable objects badly. 3 lifetimes get confused. A species persists for millions of years. A civilization for thousands. One detectable from another star, perhaps a few centuries. Humanity began leaking radio a century ago, and the leakage is narrowing. Analog broadcasting replaced by digital compression and tight beams. The loudest phase of human radio may have been the middle of the 20th century. Now stack what contact requires. 2 civilizations existing at once, allowing for light travel, one transmitting toward the other listening at the right frequency when it arrives. Fail any one, and both remain permanently alone. A society might broadcast for a century, stop, resume 8,000 years later, and be invisible for everything in between. Look at a star 1,000 light-years away, and you are reading a 1,000-year-old report. Transmit tonight, and the answer arrives in the year 3025. Letters between correspondents who will be gone before either is read. The strongest case is arithmetic that nobody disputes. The galaxy has been producing stars for over 13 billion years. A detectable phase might last 1,000 years. That ratio is roughly 1 part in 10 million. Run it concretely. Suppose 100 million technological civilizations have existed in the Milky Way, each detectable for 1,000 years, spread across 10 billion. At any moment, roughly 10 are visible. A needle problem in a galaxy that contains needles. Whoever we eventually contact is far more likely to be much older than us. Contact will almost certainly be asymmetric, and a galaxy with 10 simultaneous transmitters returns exactly the results we have. Move Earth's radio era in time and see how little it takes. Shift humanity 10,000 years later, and every signal ever sent toward us has already passed. Shift 10,000 years earlier, and our transmissions cross their sky before anyone can receive them. 10,000 years is a rounding error against the age of the galaxy. 2 civilizations can be 40 light-years apart, both listening, separated by a gap no instrument can close. Objects do not have a lifetime problem. Timing explains why we hear nothing. It does not explain why we see nothing, because many technosignatures outlast the civilization that made them. A probe does not stop existing when its makers do. Industrial chemistry persists for thousands to millions of years. If the windows almost never overlap, the search is not failing. It is sampling. Detecting a brief transmission means monitoring many targets continuously. 60 years of searching has not shown that the galaxy is quiet. It has shown that the galaxy was quiet, in specific directions, at specific frequencies, during a few decades of a 13 billion year history. It gives your sky a different texture, not empty, layered. Every star you can see is showing you a different date. unless the evidence is already here and we have been reading the wrong page. Everything so far assumed the searches were pointed correctly. They may not have been, not through carelessness, but because the space of things that count as evidence is vastly larger than the corner we have sampled. You are about to find out how small that corner is. In April 2019, a telescope in Australia recorded something it should not have. A narrowband tone near 982 megahertz, drifting in frequency the way a transmission from a moving planet would. It came from Proxima Centauri, the nearest star to the Sun, with a planet in its temperate zone. It appeared when the telescope pointed there and vanished when it pointed away. The strongest candidate in the history of the field. It took 2 years to kill. The drift ran the wrong way. It was human equipment. That is what a null result looks like from the inside. A candidate you destroy yourself. We have barely searched. Our null result may reflect a tiny sample of an enormous evidence space and assumptions formed in the 1960s. It covers signals and remote technosignatures, not visitation or local artifacts. The only answer on this map that shrinks with work. Searching for a signal is not one problem. It is a search through at least 8 dimensions at once. Where you point, transmitter power, frequency, bandwidth, sensitivity, polarization, modulation, and when you look. Miss on any axis and you record nothing, however loud the transmitter. Someone formalized this and computed the volume. The fraction all major radio searches have collectively examined is comparable to a large hot tub against Earth's oceans. That is the entire basis for the phrase, "We have looked and found nothing." Radio was chosen because it was cheap for us in 1960. It does not follow that an older civilization uses it. Optical pulses, neutrinos, or something with no current name would pass unnoticed. And technosignatures are not one class. A deliberate beacon, ordinary leakage, industrial pollution, waste heat, a physical artifact, they demand different instruments and they fail in different ways. Detectability is not existence. A civilization can be real and industrious while producing nothing our instruments register. The numbers here are published and small. A large modern radio survey examined 1,327 nearby stars across a range of frequencies and found 0 candidates. Read the sensitivity and it narrows. It ruled out transmitters above roughly 1 trillion watts in those directions, at those frequencies, during those observations. Anything quieter, anything intermittent, anything elsewhere in the band, untouched. A study examined roughly 100,000 galaxies for waste heat. Nothing in the sample was reprocessing more than about 85% of its starlight. That constrains galaxy-spanning industry, not a civilization that stayed home. Another asked about detecting solar panels on an exoplanet. Powering human civilization from sunlight would need roughly 2% of Earth's land area. A far more energy-hungry future might need around 23. Even that needs several hundred hours on a flagship space telescope that does not yet exist. A planet-scale civilization is nearly invisible. That is a calculation, not a loophole. Turn the telescope around and point it at us. Put an alien observatory 10 light-years away with instruments like our best. Not our mobile network. Earth's tower leakage peaks at a few gigawatts, and a simulation found the Green Bank telescope could not detect it at that range. It could read our atmosphere, oxygen, methane, eventually industrial chemicals. So an alien astronomer at our level, looking at Earth right now, would most likely conclude this planet is inhabited by microbes. Incomplete searching explains missing signals. It does not explain missing things. Nobody needs a radio telescope to notice a probe in the asteroid belt or manufactured material on the moon. Large-scale activity is thermodynamically hard to conceal. Computation and construction radiate. The infrared surveys tested that across 100,000 galaxies and found nothing. Defenders reply that the surveys tested one extreme model, capturing most of a galaxy's starlight. Smaller activity falls through, which is correct. But they might be undetectable is not a hypothesis if no observation could count against it. This chapter earns its place. Its claims are testable. Unfalsifiable invisibility is insurance, not science. If the searches are too small, the likeliest outcome of the next 50 years is not silence. It is a detection nobody expected. And probably not a message. An atmospheric molecule with no geological source, or an object we nearly filed as ordinary. The Proxima candidate was the search working. 2 years of unglamorous work to prove it was ours. It should change how you read every headline on this subject. Absence of confirmed evidence is a fact about our instruments, not yet a fact about your galaxy. All of that assumes the quiet is accidental. Every chapter so far has treated silence as something that happens to civilizations, a limit of biology, of time, of distance, of instruments. One possibility remains, and it is the only one in which the silence is not a limitation at all. It is a decision, possibly one you will have to make. Suppose we find one. A world 60 light-years away. Oxygen, methane and disequilibrium, structures. They have no radio. From their sky, we do not exist. Someone has to decide whether to announce ourselves. No treaty binds anyone. The first group with a transmitter acts alone. For you. Hold that feeling. It is the entire chapter. The silence may be a choice. Advanced civilizations may know others exist and decline to reveal themselves. Non-interference, caution, or indifference. It is the only answer in which the galaxy is populated on quiet, on purpose. It is also the weakest. No evidence points to it. 3 scenarios get bundled here. The first is non-interference. Older civilizations stay out of the way because contact overwrites what a younger world would become. Our isolation is a policy. The second is strategic concealment. Revealing your position is irreversible, and you cannot know whether a distant civilization will still be benign in 10,000 years. Everyone listens, and nobody speaks. That scenario takes its name from a novel. It is discussed seriously in academic work, but it began as fiction and has never produced a testable prediction. The third is indifference. An advanced civilization may not think contact with a pre-industrial biosphere worth the cost. We do not talk to anthills. All 3 move the explanation from physics to motive, the one variable we cannot constrain. The strongest case is that we can watch the reasoning in ourselves. Non-interference is not an alien invention. Planetary protection protocols and research ethics are both human versions of the same rule. Do not contaminate the thing you are studying. The debate over whether to deliberately transmit is real, live, and unresolved. Serious researchers argue that broadcasting our position is reckless and that no institution has the standing to do it for a species. Others argue the opposite with equal conviction. The debate has produced formal appeals for a moratorium, signed by working scientists. It settled nothing. That is one civilization, 1 century in, already generating a faction that argues for silence. The hypothesis requires no exotic alien psychology, only the reasoning we are already doing. Under genuine uncertainty, staying quiet costs almost nothing. Transmitting is irreversible. Only some actors need to reason that way, so make the decision yourself. The inhabited world is confirmed. 60 light years, solid and public. You can announce, observe in silence, or do nothing. Choose, then notice. The choice is not yours. Roughly 200 states, thousands of institutions, private transmitters everywhere. Your restraint binds nobody. Someone will broadcast within a decade. This chapter has just failed its own test. Humanity cannot hold silence for 1 generation. Now require it of every civilization ever. 1 defector ends it. Deliberate silence does not need most civilizations to cooperate. It needs all of them, across billions of years. Work on the structure of such arrangements suggests a genuinely galaxy-wide club is close to impossible to sustain across light-speed delays. Regional cliques might form. A unanimous galaxy could not. Silence is not invisibility. A civilization that stops transmitting still radiates waste heat and alters its atmosphere. Quiet is a policy about messages, not thermodynamics. Concealment also has a hole. If unseen observers were dangerous, Earth's oxygen atmosphere, legible for hundreds of millions of years, should have been dealt with long before radio. Defenders can retreat to indifference, which needs no coordination. That version survives. It explains almost nothing, because no instrument could check it. If the silence is chosen, everything humanity does next has an audience. Broadcasting becomes a decision made for a planet, by whoever gets there first, permanently. A governance problem with no governance. Null results would say nothing about prevalence. Every survey measuring a policy, not a population. If they are out there and quiet, the loneliness you feel looking up is not a reading of your situation. Someone did it to you, on purpose, which is where it breaks. Every version of deliberate silence explains why someone might choose to be quiet. None explains why every civilization, every splinter group, every machine, every mistake across the whole history available to us would stay quiet together, without one exception loud enough for you to notice. Nothing in this film explains the silence on its own. They are not competitors, they operate at different points in the same chain, and each leaves a different residue behind. Sort the 10 answers by what they do. 4. Reduce how many civilizations arise. The numbers, abiogenesis, complexity, the gap between cognition and technology. If they are right, every silence is explained at once. They are also the 4 we can least constrain, each resting on one planetary history. 2. Attack persistence, a corridor most do not survive, and a detectable phase of a few centuries inside a 13 billion-year galaxy. They explain missing signals well and missing objects badly, because probes outlive their builders. 1. Attacks spread. Settlement models produce patchy, steady states. Unvisited systems become ordinary. It is the strongest answer to why nobody is here, and says nothing about anywhere else. 1 attacks visibility, and it alone shrinks with effort. We have searched a hot tub against the oceans, and a planet-scale civilization would be nearly invisible at 10 light years. 1 attacks motive, and it is the weakest. A unanimity a single species could not hold for 1 generation. Remove any single layer, and the galaxy can still be quiet. That is why no one answer wins, and why the search is not a failure. Which absences remain? Ephemeral signals are comprehensively explained. Remote technosignatures are partly explained and constrained at the largest scale. Local artifacts are the least explained of the 3. No chapter here handles them cleanly, except the ones that say nobody ever existed. A layered reading is not a compromise. It is what the evidence forces. Few worlds begin life. Fewer produce complexity. Fewer still produce technology. Most of the rest go quiet or stay home. What remains is faint, brief, and scattered across a search space we have barely entered. Absence of confirmed evidence is not evidence of absolute absence. 60 years has established something precise and limited. No narrowband transmitters above roughly 1 trillion watts in a few thousand nearby directions at particular frequencies during particular observations. No galaxy in a large sample rebuilt at Kardashev scale. No verified artifact in the small volume we have examined. Everything else is open, not unknowable, unmeasured. So go back outside. The sky above you has had 13 billion years to become occupied. What you are looking at is not proof that you are alone. It is proof that the question is still open, and that nothing has answered it in a language we have learned to read. If this gave you a sharper version of the question, send it to someone whose answer differs from yours. Not the person who agrees, the one who thinks the galaxy is crowded, or dead, or simply beyond anything we have built. Subscribing keeps you with the investigation. There are more maps coming, and each takes a question this size and refuses to hurry it. And if you are in a position to help keep this work independent, membership and super thanks are the ways that is done. They are not the price of entering the search. They are what makes the next one possible. One last thing before you go. Tonight, look up for 10 seconds. Pick a star. Then hold this in your head. The light hitting your eye left before you were born, and nothing in it says anyone is there. Nothing in it says anyone is not.